Okay, so here we go. Does anybody want to ask me any questions or do they have any concerns about just the algebra stuff? Everybody good? All right, so let's take a look at some of the proofs here. So let's go ahead and mark AE congruent to FC. So that's kind of hard to do. We're trying to prove that it's a parallelogram. All right, so to prove it's a parallelogram, there's several ways to do it. We can say that, how do we say it's a parallelogram, guys? Opposite sides are congruent. Opposite angles are congruent. One side is parallel and congruent. That will do it. All right. And diagonals bisect each other, but we don't have another diagonal. So we have to figure out what we're doing. That's what we're trying to shoot for here. All right. So AE is equal to FC. So I know it's kind of hard to mark. So I'm going to do something like this. AE is congruent to FC because they overlap. BF is perpendicular to AC. So I'm going to mark that. DE is perpendicular to AC also. And angle 1 is congruent to angle 2. So a lot going on. All right. Someone want to start me out? We can just put all the given down. I don't care. I don't really need all that. Now, all we know it's a quadrilateral. Thank you. Anybody? Yes.
Couldn't we do like the segment addition postulate, like FE plus EC equals FC?
So tell me what we're trying to do.
We're trying to prove ABCD is a parallelogram.
Okay. I definitely like what you just said. All right. So tell me what you want to say.
FE plus EC equals FC.
FE plus EC equals FC. And then we might as well go ahead and say what?
AF plus FE equals AE.
FE equals AE, right? And that's again what?
Segment addition postulate.
Segment addition postulates. Thank you. So how does that help me?
Because you can prove one of the sides is congruent in a triangle, and then once you do that,
But what sides do we want to, what sides are we trying to go for here?
We was trying to prove AF is congruent to EC. So
Yes, I like that. It's trying to prove AF is congruent to EC. And then what's true about those two triangles? They'd be congruent. All right, then we have one side's congruent. All right, very nice. Very good job. So now we can say after that, what? after step 2, we can just say, tell me. Yes, because that was AF plus, say that again. So do we agree? Let me think about this. Do we agree that AE is equal to FC? And I'm not sure if I heard you correctly. So we can say, what I guess what I'm trying to say is, I'm not sure if I heard you. This is congruent to this now. Do you agree with that? Right, so we can say AF plus FE equals FE plus EC. And that's just a what? Substitution. And then we can say what? AF is congruent or equal to EC. Right, and that is what now?
Subtraction property.
Yeah, subtraction property. Okay, so now I really like that. So now I'm going to go ahead and mark these two equal. And now I really don't need this right now. This is bothering me. So I'm erasing this piece. And this piece. So now I can say those two are what? Those two are congruent, correct? So let's go with step 5. We can say, go. Oh, yeah. Thank you so much. Right. That's annoying. All right. Thank you. Yeah, I just marked those without saying it. So yeah, this, I could have written, we're definitely going to need some more room. You can write smaller off to the side. I don't really care. So yes, thank you for that. So we need to do that angle CED and angle BFA are right angles. And that's why again? Yeah, definition of perpendicular. What's with all these bells? 6. Then we can say that angle CED is congruent to angle BFA. All right angles are congruent. All right, very nice work. All right, so now we can say what? Someone. Triangle BFA is congruent to triangle what? DEC. By what? Angle, side. Which then allows me to say what?
BA is congruent to DC.
BA is congruent to what?
DC.
By what?
CPCTC.
Yep. CPCTC. Very nice. All right, so now I have one part is true. So now what else can I do? Come on, we're almost there. Two more ways. I mean, there's 2 options you can go from here. Angle ACD, you are amazing. Angle ACD is congruent to what? BAC. Why is that? No. Yes, there you go. Alternate interior angles are congruent. Right, I think this is what she's saying right here. Let's look, make sure. She's saying this is congruent to this. Do we agree with that?
Do we know that the lines are triangle?
That's what we're proving right now.
But how can we say that those are congruent if we don't know that they're-
Because the triangles are congruent. True? Right? The triangles are congruent. Oh, but wait a minute, wait a minute. The first thing first, that's not true. You guys are doing good today. All right, we should have said what? That's what?
CPCTC.
Yes, that's CPCTC, one step ahead of myself. Good job, guys. You're right. That's what you were trying to tell me, right? So that's first we say that they're congruent
Why is it CPCTC?
because we proved the triangle on the left is equal to the triangle on the right. So we know those angles are equal, just like we knew that DC was congruent to BA.
Oh.
You agree with me?
Mhm.
Yes,
But shouldn't those angles be equal to the lines of parallel?
that's what we're getting ready to do. Right, so now we know those angles are congruent. So now we can say what's true. Say it again. A, B, and C, D are parallel because, yeah, right, it's kind of the converse, but I don't care. If alternate interior angles are congruent, then lines are parallel. And then finally, what can we say? What can we say? A, B, C, D is a parallelogram
Because it's congruent.
because opposite sides are both congruent and parallel. Guys, that was really good. All right, really good. Because I made a mistake on 2 of them. All right, very, very good, some of you guys. All right. That's what I'm saying. Stay involved. Follow me along step by step. All right. Do you think it's possible to prove the top triangle is congruent to the bottom triangle? Yeah, that's possible. All right. Because we could use this now is congruent to this.
A is congruent to F.
Right. And we could do same thing, right? So you could prove that the top triangle is congruent to the bottom triangle, and then AD is congruent to BC, and then
Right.
opposite sides are both congruent, or both pair of opposite sides are congruent, right? So it doesn't matter. All right, that was really good. Really good. All right, so let's continue. 21. All right, come on, dazzle me today again, and maybe we can not do the worksheet today. All right, here we go. AD is congruent to BC. It's kind of annoying. AD is congruent to BC. Angle DAE is congruent to BCE. And line segments ACBD intersect at E. Prove that AEF, where is AEF? This triangle obviously is going to be Tell me.
So, it says that it's a quadrilateral, right?
Right. Now, quadrilateral is different than parallelogram.
Mhm.
Right?
So, and it also says G or GC or BCE is going to be DAE. So we already have one of those. And there's also vertical equals, right?
Uh-huh.
So,
I can see it now.
No, this is an additional question.
I think he's right. I think it's kind of easy, so don't make it too hard. James,
You say since alternate interior angles are congruent, then the lines parallel.
yes, you can definitely do that. And what else? Come on, James. Since what? So he just told me, which is true. He just told me that AD is parallel to BC. So what else now, James?
So angle,
Is it a parallelogram?
yes,
Why?
because a side is congruent and the lines parallel.
That's right. So now we automatically know it's a parallelogram. So now all the properties we know about parallelograms are true. So now
Does that mean AE is congruent to BC?
AE is that's correct. We now know that AE is congruent to EC. And now what? Say it again. Vertical angles. There you go, guys. Very nice. Vertical angles. All right. So now you see the triangles are congruent. All right. That's what I'm trying to tell some of you guys who think you're not very good at it or struggling with it. It's like a little puzzle. You're trying to figure things out. All right. So that's really good also. Tell me.
Wait, how'd you know they're parallel?
You know they're parallel because of alternate interior angles. That's what, you see what I'm saying, right? It's kind of hard because it's not marked very well, right? But, and that's why I always tell kids, sometimes when I do parallels or when I used to do parallels, I would make like an N or a Z. So this right here, if these are congruent, then they're parallel. All right. So that was really nice again. Really nice. All right. So let's just go ahead and write it down. I'll write it with you. All right. So let's list all of the information. I don't care about the line segments intersecting. All right. But I do want this information. That was very, very good, guys. That was given. Okay, what did you say, James, again?
So, AD is parallel to BC.
Hold on a second. AD is parallel to BC. Exactly. Why was that?
Because if the alternate interior angles are congruent, then the lines are parallel.
Very good. If alternate interior angles are congruent, lines are parallel. Very, very good. All right, I'm happy about that. All right, now, bless you, bless you. Who said that they were, how do we know there's a parallelogram? Who told me it was a parallelogram? Why is it a parallelogram? Is that you, Harrison?
I think you shouted.
No, I didn't.
I thought James did it.
Oh, that's right. James did it, right? So now we can say, James, what?
It's a parallelogram.
Right. A, B, C, D is a parallelogram.
Because when you have two sides that are congruent and the lines parallel, that's parallel.
Right. A, B, C, D is a parallelogram. And that's because opposite sides are both parallel and congruent. Okay, so now Harrison, it was you, right? What did you say now? AE is congruent to EC because yep, they bisect each other. And then Lexi, we said what? Vertical angles. And then we can say and why is that? Angle, side angle. I'm listening.
So, you know, how is it AE is congruent to BC?
How, say it again?
AE is congruent to BC.
Yes.
How do we know that the bisect?
Well, because we know the diagonals of a parallelogram bisect each other.
Okay, so do they need to be stated that they're diagonals, or is it okay if it's a concept?
Well, it says they're segments, so. Yeah, if you want to say they're diagonals, I would not be offended by that. But I trust you know those are diagonals. All right, that's pretty good. Hopefully some of you are getting a little better at it. All right, let's try the next one. 2 more to go. Uh-oh, now it's telling me ANDR is a parallelogram. And then AW and DE bisect. So because they bisect, what's true? And actually, we can just, yeah, they're equal, right? So that's true.
For R is congruent to angle.
And angle R, he said, is congruent to angle N.
If RD is congruent to angle.
Hold on. Then what?
RD is congruent to
RD is congruent to what?
AN. And then side angle.
Prove that A and W.
It's such a good idea.
Yes. Now, so then, once we have that proven, we're just going to continue with the next part, which says prove that quadrilateral AWD is a what? Which is obvious, right?
Yeah, because C.
Yes, because then,
And also AW is bisecting DN, and D is bisecting R.
is everybody okay with that? Come on now. Don't just say okay. If you're not sure, speak up. Right? Does everybody agree we can now prove the triangles, the top triangle and the bottom triangle is congruent, right? Yes, sir.
How did he know that AW is a parallelogram?
Well, what do you know that's true about AW and ED now? No. Look at the top triangle and the bottom triangle. What's true? Why? How do we know they're congruent? How do we know that is correct? 100% correct. Side angle side. Those are congruent. So now because this, I agree, some of you guys, it is hard to say if it's a parallelogram. That's why you have to know, right? If a quadrilateral has opposite sides equal, then it's a parallelogram, correct? So what's true about ED and AW now?
Oh,
That's right, they're congruent. All right, so these are equal, right? And we automatically know that what? WD is equal to EA. What doesn't say it's parallel? Say it one more time again, I'm sorry. A what? Yeah, we don't know that they're parallel, you're correct. But what do we do know? What else do we know? Yes. Right, so why do we know that? Well, no, we don't know here. And again, we don't know this is congruent by CPCTC. We know that W bisects ND, correct? Right or not?
Yes.
And E bisects AR. And AR is equal to ND. So AE has to be equal to WD. Right now, the problem I'm having is I'm not sure, you guys, you're not allowed to. I think what I want to say here is that let's go ahead. I'm going to have you guys write that out, but I'll help you write out why AE is congruent to WD. All right. So again, it's kind of like the what? Segment addition postulate we did at the very beginning, right? We know that AR is congruent to ND. What? Doesn't it say it's a parallelogram? Right? We know it's a parallelogram, and we know now that AE plus ER equals AR, and we know that NW plus WD is equal to ND. So I agree with that? And then we know those are equal, so we know that AE plus ER equals NW plus WD. Now, when it said bisect, you would put down that NW is equal to WD, and you would put AE is equal to ER, and that would have been definition of bisect. Now we're trying to say WD is equal to EA, correct? We're trying to say WD is equal to AE, right? So we're going to replace ER. Look right here. We're going to replace ER with what? AE. So we can say AE plus AE equals WD plus WD. That was kind of annoying, but kind of necessary, I thought. So everybody agree with that? This is a what? That's a substitution. And then AE plus AE equals 2AE is also substitution. And then this was the division. Property. So I think this part was what was challenging. Everybody okay with that? Yes. And the reason why I wrote it is because I wanted to make sure it was right.
Did you want us to?
What?
Did you want us to?
That would be a good idea. How?
Because if it's a parallelogram, the opposite sides are congruent. If it bisects it, then they have to be congruent anyways.
And how are you writing that? You're just telling me. I'm agreeing with you. That was obvious. They bisect. Two things that are bisected cut into two equal things. But you have to write the statements and the reasons. That's the statement and the reason. Proving that triangles congruent was rather easy. All right. Now, does anybody want to add anything to that? Right? Does anybody need to? I feel like I should just finish it up, honestly. That was a long proof. Probably the longest one we've done. Right, so over here, this was AR is congruent to ND. That was the definition of a what? Parallelogram. That was segment addition postulate, substitution, definition of bisect, substitution, division property. All right. Now that was just to prove what? That, yeah, that was just to prove what? That was now we can say that AE or AWDE is a what? We can say that's a parallelogram now. Everybody with me on that? Right, so this was always, or this should be moved down. No, I'm not arguing with you about that. I'm just simply saying that's where it belongs, right? We listed out what? We listed out the top triangle. All right, so I'll do that for you, lazy bums. All right, so here we go. Step one, what do we got? I don't care. I really don't care. You look, the point is you have to know what I've been trying to teach you for a long time is you got to know whether you know what you're doing. That's what I'm trying to show you. All right, if you're just writing it down, it's not helpful. Right? If you think, wow, okay, I can see it. Now you might have said to yourself, wow, that was pretty hard. And you now understand it as we're going through it. All right, but when I ask you to write a proof on the test, you know, you're going to have to do it. So here I was just stating this piece is to prove that that quadrilateral is a parallelogram. Now, I can't really prove that it's a parallelogram until I prove that the top and the bottom triangle are what? Congruent. And that wasn't a very difficult thing, right? Because we could say that was side angle side, correct? Yes, tell me.
I have a question about the reading on this tonight. You know the 2AE equals 2WD?
Yeah.
Why do we need that? Can't we just subtract it?
What are we subtracting?
Oh, yeah, can you just do subtraction when you go to AE plus AE?
Is there a division process?
What are we subtracting?
Oh.
What are we subtracting?
Yeah, because you haven't proved that AE equals WD, so you can't subtract.
No, but if it says AE plus AE equals WD plus WD, shouldn't AE plus WD just equal? Shouldn't it just equal?
But we're in math, we're not allowed to say they're just equal just because I know it's true. We got to say AE plus AE equals what? 2AE. Right? And then we divide both sides by 2. I know it's annoying. I agree with you. I can look at this whole thing and say it's all true. Right? But you have to show me it. You can't just say, I know that's true. All right. Okay,
We have to do all that then to prove the ER and W are congruent.
say that again.
We have to do all that to prove the ER and W.
Oh, that's a good point. Yeah, NW, we have to show that NW is equal to ER.
Yeah.
No, this is definitely, what I'm gonna do next year is I'm just going to draw the statement reason on the whole page. Right.
Delete the other one.
As a matter of fact, as a matter of fact, I'm gonna fix it right now. Thank you for that.
You can just delete number 22. You don't mind.
No,
Yeah.
Can you, yeah, can you just?
Oh my God.
I kind of want to.
you can keep it.
First year.
Can I just not do geometry?
There we go.
It's fun, but like.
No, it's not.
What are you talking? It's brilliant. What are you talking about?
Really, it's so fun. It's so
But after this is fun.
Proofs.
Oh, I love proofs.
Words are just my favorite.
Let's just keep it true. I actually hope you watch it.
All right, now it's fixed for next year.
Oh, yeah.
There we go. Next year, there we go. There's 22 for next year. All right, that'll give my algebra kids plenty of room to write in. And I bet you they won't whine like you guys
Oh,
do.
no, they will. They will.
Oh my gosh, do I have to do that also? Oh my gosh. Yeah, I'm gonna be crying all day. All right,
Yes, please.
so here we go. So let's figure out 23. All right. So is this one any more difficult?
No.
Copy,
Don't do
paste.
Literally, I fit.
Would you love to have a cookie?
Here we go. Now what we want is to get the statement and reason. Just. All right, let's have fun with this one. I don't know how you're not saying this isn't fun.
It's gonna be like 7.
All right, so we know it's a parallelogram.
Oh, second?
Yeah, we can go to 23.
Yes.
You guys are whining.
Wasted.
All right, here we go. So I have parallelogram DEFG. So DEFG and K and H are points on D such that we want to prove that DK, bless you. We want to prove that DK is congruent to EH. Now, because it's a parallelogram, we know this DEFG is equal to this, right?
JK is.
And we know that this is congruent to this, right? So it looks like we're trying to prove the triangle on the left and right are equal. Is that what we're trying to do? Oh, yeah, I didn't write that. Angle DGK, this guy, is congruent to angle EFH. This right here.
Would you say GDK is corresponding to E or FPG?
Okay, say it again.
GDK is corresponding
GDK and
to FEH.
yes. Wow.
And then it says
Yeah, that's a piece of cake then. Right. This right here is equal to this right here. Okay, so write that out for me. Finish writing it out. Everybody's writing that one out. And then we're not going to do the other worksheet, but we're going to pull it up. Okay. I finished writing that out.